We are here. Yes, I'm late, Taparium. I'm sorry. Please forgive. I screwed up my encoding settings, which not. Let me just make sure.
Yes, I'm late, Taparium.
Okay, yeah, I screwed up my encoding settings. I had my frame rate at 29.97, and apparently with the encoding I'm using, I can only use 30, so that 0.03 set me off by a minute. Yeah, I'm late. Sorry. All right. Well, now we already have to ban people, so that's lovely. You know, with the amount of people I've already banned, I can't believe that I still have to ban people. All right, so we've got about 13 minutes until Nvidia goes live. You can see in the bottom, I think that's the right-hand corner for you guys. Might be left. Should be right. That's their Twitch channel. They're still not live yet. We'll switch over to them as the main screen once that happens, and we'll be good to go. How's everybody doing? It's good morning to you guys from South Africa. It's currently 5:48 a.m. Been up since 4:30, as I normally am. And waiting for you guys to join and watch this CES stream, which I don't expect to be as disappointing as the Gamescom one. I think that it's going to be enjoyable. I'm okay with the 2060 6 gig for $350. People got upset in the video talking about how, the 1070 Ti was $350. Technically, but that was also when it was on sale on its last leg. That's not its MSRP. The MSRP of the 1070 Ti was $450. So $100 off of the 1070 Ti for the same performance. Technically, the MSRP has come down. And then if they implement deep learning super sampling with ray tracing, then we should be able to get decent frame rates at 1080p in a lot of games. Shout out from Dallas, Texas. Thanks, Ivan. Much appreciated. How you doing? Good evening to you there. Good night. When is it starting? It starts at 8 p.m. Las Vegas time, which is 6 a.m. South Africa time, which is in about 10 minutes. I cut off a leg for that 2080 Ti. Good job. Proud of you. You're willing to sacrifice the way that most people should. It just works. The RTX are crap for ray tracing, but the deep learning super sampling shows promise for higher resolution gaming. The RTX aren't crap for ray tracing. It's just the only implementation we have is Battlefield, which isn't even implemented properly to use the hardware, which could be NVIDIA's fault, especially since they're pushing Battlefield as like a key game. So it's 50-50 there. As soon as we get games taking advantage of the ray tracing cores, it should be fine. From what I'm hearing in the pipeline, Metro Exodus should be that game. It should be the ray tracing title. But how many people will really invest in the Metro series? Like, I'm sure there's a lot of diehard fans out there. I'm sure a bunch of you in the chat are going to say you love the series. But at the same time, it's not a massive franchise. It's starting at 11 p.m. for me, and I'm tired. Rip. Sorry, my friend. Happy New Year. Happy New Year. It just works. I've got the soundbite for that.
Everything just works.
Everything just works, my friends.
Everything just works.
Oh, we got two of them at the same time. I've got a soundboard now, in case you wanted that for a live stream. You don't. I'm not going to abuse it. I'm sorry. You have a hoodie for that? Nice, Michael. Thanks for picking it up. It just works. Tried to play Battlefield 5, somehow less optimized than the first week. So tried playing it. Sorry, friend. When does it start? We've got 9 minutes. 9 minutes. As you can see in the bottom right-hand corner, we got it on watching for it. And then once it goes live, we'll go bam, full screen. I'll full screen the Twitch thing too, so don't worry about that. We got it. We're set up, I think. The audio might have to be tweaked here and there, but it'll be mostly okay. It just works. Love from Kenya. Thanks, Imran. Much appreciated. Is the Ryzen 3 announcement made yet? Only for the mobile side of it and the APUs, as far as I'm aware. AMD officially announced those, but AMD's keynote, where they're expected to launch the official Ryzen 3000 series, will be on Wednesday, the 9th. Do you think we shouldn't be that hyped in AMD CES? I think the rumors super enticing. Should you put your faith in them? Probably not too much. Oh, we got movement. Oh, we'll begin shortly. They're using Twitch this time instead of that awful, what was it, Ustream platform they did last time? It's not okay. Yeah, with AMD, obviously the Adored TV rumor is super tempting, super scrumptious, something that basically everybody wants. So, yeah, if it happens, that's amazing. If it doesn't, we gave AMD too much credit and they disappointed us once again. Which I don't know if that's their fault or if it's our fault. Isn't it like 4 a.m. in South Africa? It's almost 6 a.m., which is fine. I get up at 4:30 anyways. New code name for AMD. No, I saw that one. I just haven't had time to do it. Oh, we got Nvidia Motion. Ooh, they're ray tracing the logo. This is perfect. This is everything I wanted. Nvidia, it just pretends to work.
Everything just works.
That's all you need. Are you going to live stream all the talks at CES? Probably just this one and AMD's. The ones that most people tend to care about. No, CES hasn't even started. Apparently, Nvidia wanted to get the jump on the whole thing, so they're doing it on Sunday evening when CES, as far as I know, officially starts on Monday. So if AMD delivers, do you think Nvidia will drop their price? No. I don't see that happening. Loved your $500 build. Thanks, my friend. I think this is an NVIDIA mobile RTX for laptops. I'm sure that's going to comprise part of it. So the things that I'm mostly expecting from this announcement are, yes, as you mentioned, the mobile. So 2080, 2070, 2060, all max Q versions as well. And then we should also get the 2060 announcement. We should maybe get a 2050 announcement here. They could just put that on sale without saying anything, just release a press release for that, and that's going to be totally fine. And then there was one more thing. The BFGDs, they're going to talk a lot about that. So that's their big freaking gaming displays or big format gaming displays. The 65-inch that costs $5,000. I think the first one was announced from HP. Not worth $5,000, but if you want the best gaming display that's giant on the market, then that's going to serve you well there. So 2060, mobile cards, BFGD, all of that. How come donate button gives an error? No idea. I haven't looked into the donate button in a while. It's working fine on my end. They probably don't have enough GDR6 for mass consumers that buy the 2060. Maybe. Can you do a special where Tank hosts hot news? No, he doesn't want to. It's totally fine. Not going to force him to do that. Like, the reason I'm the host of all of our videos is because I'm the only one who is willing to do it, essentially. Like, Ricketts did that one time when I was sick, but other than that, it's just, we don't script hot news anymore, so it makes it difficult for him to do that. They'll get used to it. It's a lot harder than you think. I mean, once you are used to it, it's fine. But even just having, the prerequisite understanding of how to talk about things is like something that you have to build up over the years. And sure, they have it, but the ability to construct sentences on the fly that are at least somewhat topical to what you have to talk about with the news article is it's simple for people who can do it, but it's also super intimidating and complicated for people who have no experience in it whatsoever. Speaking of YouTube Rewind, Alex, we will be releasing we're super late on this. It took me a while to get to it, but we will be releasing a YouTube Rewind Tech Edition, either later today or tomorrow. So keep your eyes peeled for that. It's been a lot of effort. I think we featured like 100 different videos from like at least 30 to 40 different creators. So it was a big project. We're over a month late on it, but we worked our butts off on it, and hopefully you guys will enjoy it. How much longer do we have to wait? 3 minutes, supposedly, if we're going by official start time. Rewind, it's 2019 now. Well, what would be the perfect time to rewind 2018 when it's over? That makes sense. We're like 7 days late because the 31st counts as 2018. Can't rewind 2018 in 2018, except for everybody did. Does it have Will Smith? Of course it does. You can't have a tech rewind without Will Smith. It's rewind time, everybody. Yaw! Do you think they will release 2050? It's possible. The leaks on that have been less than the 2060, so it could be that it gets announced here, but then we're still waiting until like February or March until it actually releases. The 2060 is this close to releasing January 15th, so we only have to wait a week. But it seems based on the amount of information we're getting from everything else that it could be announced, but the actual release of such products isn't going to happen. So the only thing that we'll have to be cautious about with this stream is the audio is probably not mixed correctly. I'll more than likely have to drop my mic. You guys in the chat will just have to let me know if I'm too loud. But we're going to do our best to get it to the point where everybody's hearing everything properly. There we go. It's rewind time, everybody.
Everything just works.
Isn't CES on Thursday? No, CES starts on the 8th. It's the 8th through the 12th, officially. There's sound. All right, we'll see what it sounds like. Give me a second. I don't hear any sound. I don't want to view their Twitch chat. That's just too much for me. And then let me just pull this up, and we should be good. Everything just works. Yeah, there's no audio on their end. It's full blast on my side. So when it's there, we should hear it. AMD's Tuesday. No, AMD's Wednesday. It's on the 9th. So Lisa Su is doing the opening keynote of CES, but she's not going to be announcing that many AMD products there. The actual AMD announcement's taking place on the 9th, and they're live streaming it over on YouTube. So we will be live streaming their live stream, of course.
Everything just works.
That's all you need to know. CES starts on the 8th. Now they're late. I started late. Now Nvidia's late. What's up with this? What time for AMD? It is 7 p.m. South African time, which should be noon Las Vegas time. Sorry for the high pitch there. That's my thinking voice. They waited on me. Yeah, well, now we're waiting on them. I do enjoy this ray trace logo though. You can see even if you look hard enough. I'm going to shut up now. No, I'm not. If you look hard enough, you can even see that they had the little Space Invaders that come up on your RTX 2080
Ladies and
when it
gentlemen,
crashes.
please welcome Nvidia founder and
Jensen
CEO, Jensen Huang.
Yes. All right, so how's the audio compared? What does it sound like, guys? That's as loud as they're getting. I can turn myself down, though, if you need me to. Obviously, we'll wait till it
Happy
starts
New
talking.
Year!
Happy New Year.
Welcome to CES.
Thank you.
I have so much to tell you guys, so I'm going to get going. Usually at CES, I talk to
Everything
you about
just
self-driving
works.
cars and gaming. Today, I'm going to focus completely on gaming.
He's super out of breath.
Either you're excited about gaming, or you're excited not to learn about artificial intelligence,
Can you turn
robotics,
down
and
the
self-driving cars.
monitor? I'm gonna turn up.
But anyways, we have so many announcements in self-driving cars and autonomous vehicles
Actually,
as
don't
well.
worry about it.
Over the course of the next several days, you're going to hear a lot of news about our next generation of autopilot technology, how we're applying artificial intelligence to the user experience of the car, and how we're using augmented reality to provide feedback to the driver while they're in the car, while the car is driving by itself. We're also announcing a whole bunch of partnerships.
He said he was going to talk only about gaming.
I ran down that hall, and I'm breathless.
Everything just works.
And so we're also announcing a whole bunch of partnerships with map makers all over the world. Between our technology and their technology, we're able to drive in so many different places in the world, whether it's Europe or Japan or China or different places in the United States. So be sure to go see our booth. There's all kinds of amazing technology. Today, I'm going to focus on gaming.
Great.
The GPU revolutionized modern gaming.
Chicken Christ.
There's absolutely no question about it.
Grammetry.
If you take a look at the last 15 years, which I've shown you a brief history, visual history of computer graphics for video games and some of the most important games that have come out over the course of the last decade and a half, and the technology that made it possible, GPU was at the center of all of that. The fundamental technology that enabled all of this advance was rasterization. Basically taking geometries in a virtual 3D world and translating those geometries, those triangles, into dots on your screen called pixels.
Jensen,
that translation
please.
process, converting triangles in 3D space,
It's like he has
pixels
one
in 2D
keynote.
space, screen space, is called rasterization. Rasterization
He has one keynote for the
is
professional
incredibly
crowd,
efficient.
and then one keynote for
Computers do it
the actual
incredibly
gaming
fast.
crowd.
On top
Every
of
time.
that, we applied texture mapping that allowed us to put interesting decals on top of three-dimensional objects. If you take a look at Battlefield 1942, this is one of the favorite games of my kids and I. 2002, if you take a look at that video game, basically there are texture maps on top of 3D geometries. And it was incredibly fun. It was groundbreaking technology at the time, but as you can see right now, it was very chalky. Lighting effects weren't right. There were very few shadows, if any at all, but yet it was incredibly fun. Gears of War took advantage of a technology we invented about 15 years ago called programmable shading. Programmable shaders allowed us to take that pixel that's on your screen and apply a complete large program to it, a really, really flexible program that allowed us to apply all kinds of interesting special effects. Epic, the creators of Fortnite, applied two basic technologies on top of what was available at the time. And one of them was called light mapping, light baking. Basically what they did was they applied the techniques of making
You
video
can't sell
games
graphics cards if it's not for Fortnite.
to the
We all know
creation
this.
of the textures. They did global illumination, beautiful lighting in advance of creating the textures. And then they baked the lighting into the textures. As a result, you could see all kinds of interesting shadows that emerged. They applied also on top of that this thing called pixel shaders that we invented that allowed them to create bumpy and shiny type of effects. Notice how beautiful Gears of War was.
Jensen,
Crisis
please.
in 2007
We all
was
know
a
about Crisis. Please,
groundbreaking
Jensen.
piece of technology, CryEngine. What they did was they applied really, really fantastic new technologies and took programmable shading to the next level so that we could take these realistic worlds outside,
feel like he does
where
this
it's
on
very
purpose.
difficult to bake.
He knows what
Whereas you
everyone's
could
here
bake
for.
light
He's a
inside a
CEO,
room
not a
like
presenter.
this,
So
and then put that essentially into a texture map. It was very difficult to do
He's
that
doing
outside
this for the
in a
shareholders,
dynamic
not
world.
the people who
There's a
buy his
lot more
products.
geometry, lights changing all the time. As a result, shadows are changing dynamically. They use depth of field to take what appears to be in the distance and what appears to be close by, and the close by objects just popped. Screen space ambient occlusion is basically that little dark shadow at the creases of geometries that you see, where where that little tiny piece of geometry lacks the exposure to light. Crisis was a groundbreaking piece of game, and as a result, video games really took a giant step up. Battlefield 3 took it to another level, applied that basic technology, added tessellation, so geometries were really, really rich. We saw no more facets on most of the characters, and when there were explosions, physics were applied, computational physics. Like a supercomputer, physics algorithms were applied so that buildings would crumble, there would be wonderful smokes and
the
particles.
best part is he's going to run out of time for the
Battlefield
keynote and
3
have to rush everything at
was
the end.
groundbreaking visuals. Battlefield 5 took it yet to another level.
You can
with
see
the
how
technology
flustered he
Yes,
gets.
he skipped Battlefield 3.
photogrammetry. Essentially taking pictures meticulously of the world. Taking pictures meticulously of the world and de-lighting it, taking the lights out of it. And what you have left is this beautiful image of the real world, which is then applied as a texture map. That texture map, then applying with all of this great technology and pixel shading, turned into what we see as Battlefield 5. It basically looks like a photograph, and you're in this world interacting.
No, it
with
doesn't.
It obeys the laws of physics, and it obeys conservation
Look
of
at
energy.
this photograph.
So what looks inside this room, inside this world, is physically accurate, what we call physically based rendering. You look at the course of the last 15 years, the technology has advanced tremendously, but
I
yet,
can remember when Crisis first popped
You
up.
stand back.
Like, that felt like a real jump.
That's 12 years ago.
and it still
Exactly.
That kid would
looks
be in
largely
like 6th
like a
grade.
cartoon. And the reason for that is because there are three things
But yeah,
that
like-
are kind of largely missing.
I haven't felt like
There are
there's been
three things that are
a
largely
huge
missing.
jump like that in a while.
Ray
Reflections
tracing,
aren't
Reese.
right.
Shut your mouth. You don't appreciate it.
Shadows
Savage.
aren't right. And refractions are really, really hard to do. These three lighting effects are really hard to do in rasterization. And yet we apply all kinds of amazing tricks to work around them, but it's just really, really hard to simulate the effects of light by starting from a geometry.
Everything just
Because
works.
you have to start from the light. And that's where ray tracing comes in.
You've
About
missed
30
that
years
button,
ago,
haven't
one of
you?
our
Everything
researchers
just
dealing
works.
with
It
it,
just works every time he says ray
invented
tracing.
a technology wrote a paper on iterative ray tracing, and it's taken over 3 decades for the entire industry working together to try to find a way to do it in real time. Tracing a light from your eyes into the world, from your eyes because it's the most clever and the most energy efficient way of doing it, instead of from the light. You trace it from your eyes, only the things that you see. Where it intersects a triangle or an object, it would then follow to the next point of light, whether it's reflected from another object or from a light source. And every single time light touches that geometry, it would affect the color of the pixel, the lighting of the pixel that comes to your eyes. One ray at a
Nvidia
time,
eyes
we would
2.0.
trace it into the world. And just by doing that, which is basically simulating the laws of physics, the way that light works, and if we capture the materials, we capture the light transport behavior of the medium, we capture the geometry, and if we could do this fast enough, shadows just appear.
They just appear.
In the real world.
As long as you go fast enough.
Lighting just works.
Gotta go fast.
Reflection just works.
Everything just works.
Materials look rich. It just works. No light baking
Well
is
done.
necessary.
Jensen.
No faking is necessary. It just works. That's the beauty of ray tracing.
Everything just
However,
works.
The computational requirement is just daunting. And it's
Oh, it
taken
makes me
us
so
3
happy.
decades to get here. And let me show you some of the inventions that we think will be necessary to take it to the next level. And so if you take a look at the top, reflections on ray tracing. RTX on, notice everything is reflected as you would expect. The Rubik's Cube reflecting on the ground, in the mirror, in the sphere. And when we turn, oh, may I do it again?
Oh, no.
How do I do that? Hey, Patrick, help me.
My.
I know we're being broadcasted. It's okay.
They
We're
must be
among
using an
friends.
AMD card.
How do I go back? Do I go back?
There it is.
Or do you go back? Ah. Okay.
Oh,
This is
that's
what happens
terrible.
when
It's
you-
like a PowerPoint.
You don't rehearse.
I can't even rewind it.
Dang.
Okay, so reflections, RTX on, notice everything just works nicely. In the case of rasterization, it uses this thing called a screen space reflection. So it basically takes what is drawn into the screen,
Seems a
into
little
the frame
flustered
buffer,
now.
as the
He's always
reflection
flustered.
map. And if you can
Whether
see
he's
it
throwing out
on the
sandwiches or
screen,
running
if
to
you
the
can see
stage.
it on the screen, then it could use it as a reflection. Unfortunately, the things in the back of
Still
that
sad we
Rubik's
didn't get
Cube,
Jensen
the
sandwiches.
things on the back of that Rubik's Cube, you can't see. And therefore, as a result, it can't be used
Who
for
did we
screen
choose
space
over
reflection.
NVIDIA?
And so the back
I
of the
think it was
Rubik's
MSI.
Cube, which is being reflected into the mirror,
Was it?
because
Yeah.
the mirror can't see
Can't
the back
remember.
of,
That
using
it's like a blur.
rasterization, can't see the back of the Rubik's Cube, it can't use it for a reflection map. The same thing in that little tiny shelf on that mirror, if I were to turn off RTX off, you would notice that it's broken. Another thing that
If he was
ray
able to.
tracing solves
But he
is
can't.
shadows. This right here is called the umbra. Umbra's Latin word for
Penumbras.
the eclipse, otherwise known as the
I
shadow.
was waiting for that.
In the case of rasterization, it simulates a shadow by essentially drawing the projection of the shadow on the ground into a geometry. And it does it by using a point light. In the case of area light, some of that light goes to this side, some of that light comes to this side, and as a result, the umbra and the penumbra, the partially occluded parts of the shadow, are not crisp and clear. I wish
Please tell
this
me
would
they
go
just work
over
with ray tracing.
again so I can show you. As a result of using ray tracing, we can now have soft shadows. Global illumination. Global illumination is
Hey,
necessary
you got it to work
when
after
you
you walked
don't
away.
pre-bake the lights.
That hurts.
If you pre-bake the lights, if the world changes on you in the video game,
He said he was
all
going
of
to
a
talk
sudden
about
your
games
pre-baked
and
lights
gaming.
don't work.
Yeah.
He's not. He's talking about game development,
And
which
so
is a
notice-
different subject.
This is RTX off, and when the building falls apart, the lighting is just wrong. RTX on, when the building falls apart, it still works. Okay?
Everything
One of
just
the things
works.
that you notice in most video games is the animation is really, really hard to do. And the reason for that is because the world is completely infinite. It's different everywhere you go. And now, because you want to have destructive geometries and transforming geometries, you never know exactly what world you're physically going to be interacting with. Motion capture is nearly impossible for that entire diverse, infinite different degrees of freedom. We use artificial intelligence to train the agent how to navigate. So this is a piece of work from the University of Edinburgh, and the researchers trained an AI how to animate. Facial rendering is one of the ultimate challenges, and the reason for that is because the way the area light affects the face, soft shadows, the occlusions, somehow you see just slightly into the mouth. That's possible because of global illumination. Your skin is semi-translucent, so refraction, the ultimate versions of refraction, called subsurface scattering, all of those effects apply. And then, of course, we want to animate the face. The combination of all of those effects makes it super hard to do with rasterization. That's one of the reasons why most of the video game characters look a little bit chalky and like cartoons. In the future, we could use ray tracing and deep learning and artificial intelligence to make faces that look very human-like. And of course, image processing. Artificial intelligence has the ability to learn what is the right image to synthesize. And maybe as a result of that, we could use lower resolution textures, less amounts of textures, and use artificial intelligence to synthesize the virtual world because, quite frankly, it's natural anyways. And so AI could use it to synthesize higher resolution images. AI could use it to synthesize textures and synthesize all kinds of interesting geometries that we can explore within. AI and ray tracing are two fundamental pieces of technology that we believe will define the next generation of computer graphics.
Okay, give us more, Jensen. Come on.
Everything just works.
And no, he's got more.
Give us more. We want
From
it.
now on,
Yes, please.
when Paul says 1.5 minutes, I'm going to believe him. Last time he said 1.5 minutes, it was actually another 5 minutes. And then he said, then all of a sudden, Cheryl was calling my name on the incredible.
Paul and Cheryl. Jeez. He's throwing his dirty laundry out
We
there.
invented a new computer graphics technology to enable the next generation of graphics. We call it RTX.
Yes, we know.
The Nvidia RTX.
Thank you.
In order to enable the next generation of computer graphics, in addition to rasterization and compute shaders, we had to add two new ways of computing. One is ray tracing, the ability to trace a ray through a complex world and do it as fast as possible. And then number two, artificial intelligence. Artificial intelligence for the synthesis of worlds, synthesis of images, synthesis of animation. These four key technologies are going to form the foundation of the future of computer graphics. What now the industry is calling, leaders in the industry are now calling hybrid rendering, to combine all of these different types of technologies to generate the final scene and to generate the final AI world, the virtual world. We call it the Nvidia RTX.
We know. Please.
It took 10 years for us to reach here. For the last 3 years, we've been working with the industry to create this entire stack.
And it's taken us
Building
6
the
months to get a new
foundational
keynote.
technology, integrating it with all of the
Is it really
APIs
different?
He's not about to
available in
get
the world,
fired.
extending it for ray tracing, extending it for
No,
AI,
somebody released
and then
a video,
integrating it into game engines like UE4 and
This
Unity.
could be Jensen's last year's seed.
We then
He's the
built
founder of Nvidia. He's not
a
going
brand new
anywhere.
I don't
GPU
think he's going
They're
anywhere.
still making plenty of profit.
power
They're doing well for the
this
future.
new
The only
rendering
people they
system,
pissed off is gamers.
the
But they
Nvidia
have a
RTX.
huge market in
We call
AI
this new
and
GPU
with compute and
Turing.
Yeah, no, they're
The
fine.
Turing architecture,
I
the
don't
Turing
think
he's
architecture
going anywhere.
basically consists of four things. The first thing, of course,
They might get
is
somebody
the
else to do the
GPU
keynotes,
itself.
but he's
the
still
Turing
going to be the
GPU.
founder and CEO.
The second is a brand new shader architecture. The shader architecture of Pascal has floating point engines on top that are either doing floating point, shaders on top that are doing floating point or integer, but not at the same time. It has L1 cache, shared memory that are separate, and it has a 3 megabyte L2 cache. In the case of Turing, we made it possible for us, we doubled the amount of computational units so that we can do integer or floating point at the same time, and floating point at the same time. And we unified the L1 cache and the register files so that they could be much more fungible. As a result, potentially, depending on applications, adjusted to be twice as big as the Pascal generation. In the case of L2 cache, we doubled its size. We added a brand new engine called Tensor Cores. Tensor Cores has the ability to operate on the deep learning network's fundamental operation of linear algebra A times B plus C, 4x4 linear algebra matrices at the speed of light. It can operate on 4x4 linear algebra matrices, A times B plus C, in one single clock. And it could do it across a whole bunch of modules. And so basically, hundreds of terafloating point operations per second could be processed in one single clock. Okay. We call
This
it
is
the
all
new
amazing.
Tensor Core. And then lastly,
I'd be blown
in order
away
to
if
do ray
this was the first time I was
tracing, we have a
hearing it.
dedicated functionality called the RT core, the ray tracing core, that basically flies through this data structure called the bounding volume hierarchy, which describes the geometric world and deals with all of the intersections of which triangle is hit by the ray and what other rays are spawned from it that is called the RT core. These 4 characteristics describe the Turing architecture. The performance, the throughput is incredible compared to Pascal. Pascal starts out with the largest version of it, which is now in
Everybody's
the
taking
Titan
pictures with their phones.
XP.
Yeah, I can.
These
And
slides haven't been
Turing starts out
public
with
in
the
months.
largest version of it, which is in the Titan RTX, what some people call T-Rex. These 2 largest
You
chips
guys called it T-Rex.
is what the
Nobody
entire
calls it
family
T-Rex.
of
You guys
Turing
do.
and Pascal are
Yeah.
derived from. In the case of Pascal, the largest chip is 11.8 billion transistors, almost 500 millimeters squared, has an I/O of 11 gigabits per second using the fastest memory at its time called G5X. In the case of Turing, 18.6 billion transistors, 754 millimeters squared, and 14 gigabit per
That's a
second,
big
the
boy.
fastest memory you can use today, called the G6. These 2 dies
G6.
is what the entire family is
Like
derived
G6.
from. And if you take a look at
Fantastic.
gonna make
these
that
2
joke.
dies and their computational throughput, you can think of it this
T-Rex
way.
equals little arms. This is how much I can ray trace.
Just that.
The compute of Pascal,
My question is, do consumers even care about all this stuff, or do they want the new fast cards?
here we go.
Yeah,
The
because it's the
compute
consumer
shaders of Pascal
electronics
is
show.
12
so
teraflops. In the case
but he
of
did this at
Turing,
Gamescom too.
it's
This is just
16
Jensen.
plus
Should
16.
appreciate it.
16 teraflops, trillion
I think
floating
something
point
went wrong with the
operations per
slide
second,
again.
and 16
Let the technical
trillion
difficulties
integer
happen.
operations per second.
That's what makes it beautiful.
The shared memory and the register
Performance
files is
art.
12 megabytes large.
It's like
in the
interpretive
case of
dance, but with
Turing,
slides.
25 megabytes. In the case of L2, 3 megabytes to 6 megabytes. Basically, Turing has twice the basic throughput of computational compute horsepower. And if you then add on top of it the 2 new processor cores for tensor processing and ray tracing, you get, in the case of Turing, 130 trillion operations per second and 11 gigaarrays per second. Now, it's possible for us to use Pascal to do both of those things. And the reason for that is because Pascal is a general purpose compute program accelerator. And so it could run tensor operations, just about 1/13 the performance, about 1/10 the performance. In the case of ray tracing, it could also run ray tracing. However, it would have to run it at about 1/10 the performance. You take all of this computational capability and you put it inside this compute framework we call RTX, and on top of the driver called DXR, accelerating driver called DXR, and then integrating it into the Unreal
gonna show us
Engine,
Battlefield 5
we
now?
can then apply that to do amazing things.
I'm pretty sure
This is
Battlefield's
what I'm going to
gonna
show
work
you
its
is a
way
demo
into
we've
this
shown you
again.
before, except we've made some
Hopefully
refinements,
Fortnite.
if you will.
I'm looking for some
so
ray
let's
trace
enjoy
Fortnite.
this.
You mean it's not?
Oh, this is the thing that they did at the end of the Gamescom one. We're gonna get copy strike for this again. All right, so what you guys are about to witness is a dancing robot. All of this is ray traced using Turing cards, or they're not going to show the dancing robot. No, they are. So everything up until this point has been everything he said at Gamescom, which has been fantastic. You know what? I don't even need to see this full screen. We've already seen this.
I can see myself.
This all happened August 20th. We're about 4 months removed from this. Oh, they changed it. Wait, no.
No, that's the same.
Oh, he just puts on a suit?
Yeah.
Did I just forget him having a face? Video volume's too high? Spin. Hopefully that's a bit better. He's so shiny. Look at all those reflections.
So much ray tracing.
Which, it's great. Ray tracing is amazing, but, like, this still looks fake. It's not like ray tracing makes it look real.
It looks like B-grade movie graphics.
They should have just put Jensen in the suit.
Would have actually loved that.
That would have made more sense. Yeah, they haven't given us the balls yet. could ray trace
The
walls.
ray trace
I
walls.
guess, like gamers want that at Gamescom, but consumers at CES don't want it. Oh wait, this is different.
Yeah, there was no jump last time.
There's more to the story. We've been deceived, bamboozled.
Best boy.
That should be Jensen. It's the new Mass Effect. Yep. Perfect allegory for the game. Can't pull itself out of its own doing. Like, this is cool for movies and, like, actual cutscene development. This is terrible for video games. This is not how it looks.
That's a dislocated shoulder.
That looks like a bad video game. All of that dust and no. The reflections in that mirror are cool, though.
Houston Jensen after the press conference, like, I'm Iron Man.
Can we shut up? Jensen's gonna be back now.
Ladies and gentlemen, everything you just saw, all the lightings, all the shadow, all the animation, everything, all the ray tracing, 100% of it
Just
was
works.
in real time. This is not a movie.
It definitely was a movie.
This is next generation graphics. This is what RTX enables. This new form of computer graphics that brings together rasterization for the things that it can do very, very well, ray tracing for the things that it just simply can't do, artificial intelligence that I'm going to talk about later, and, of course, programmable shading that we invented 15 years ago.
You know, they did the
We could
fast
change
part
the time
as a
of day, we
movie,
could
and then
change
this
the lighting
part
effects.
is real time.
It just
because
works.
you don't see the frame rate as much
All
on
the
this.
reflections just work, and the self-reflections work. You could see the reflection on his armor from his arms. And it doesn't matter how you rotate the camera. It doesn't matter what moves around it. The lighting works, the shadow works, and the reason for that is we're simulating light, and it should behave accordingly. Sean, that's fantastic. Everybody, that's great work.
Everything
Guys,
just
let's
works.
put a hand together for the engineers and the artists of Nvidia. Thank you. Thanks, guys. And so that's a demonstration of what's possible in just really a few short months when RTX came to life and what we've been able to do to demonstrate its full
had that ready
potentials.
before RTX
Notice
was
how
out.
incredibly physically real it looks. All the materials look so realistic. The lighting looks so realistic. Because our eyes are so acute and we pick out such small details, if the shadows are off, the reflections are off, the lighting's off,
You get over it because it's a video
we
game.
notice right away that something is wrong. This is the next generation of graphics. This is the beginning of next gen. Our partners have been working with us to advance this.
Oh, they're going to show this
And
again, I
working
think.
with Industrial Light and Magic,
come on, please don't.
Epic, who
This is
is
like
the
the
creator
85th
of
time.
Fortnite, the creator of the Unreal Engine, and the engineers at Nvidia, we were able to bring together all of the pieces of technology to enable this new platform, this next-gen platform powered by
they're gonna show it.
RTX. And I won't show the full demo, but I'll show you a short video clip of what that looks like. If you go to our booth, and of course it's all over the web, this particular demo is just so inspiring, and it shows you what's possible with RTX.
So inspired. I mean, to be fair, this is a cool demo that we don't get to see.
What's the story with all the elevators lately?
We just get to hear it.
heard
I love this.
Kylo Ren destroyed the one over in D sector. Who's ever in charge of this place should be transferred to Hoth.
It was
What?
impressive when it first came out.
Yeah.
And it's still technically impressive, especially if it's rendered real time like they say it is off of one Turing card. But if they could just stop.
This one new?
Come up with a new one, please. It's
You
beautiful.
think
though.
she heard us?
Like it could be a follow-up
The
to
amazing
this one.
thing,
Yeah, like
isn't
an
that
additional
incredible,
story.
guys? Let's put our hands together for the
Like if they could just create
all
a
the
storyline
engineers that
each
worked
time
on it.
and then weave a complete narrative.
The
and make an entire new
reflections,
Star
the
Wars movie.
self-reflections, all of the dynamic reflections, all happening in real time. And so if you look at the shadows, you look at the reflections, they just all look quite normal. The materials look normal, and the reason for that is because it's being simulated properly. Another example that we demonstrated, this one I think we did at SIGGRAPH just in August, was another piece of work that we did with Epic and the folks at Porsche to celebrate their big anniversary. Guys, let's play it.
Oh yeah, we saw this one. This one's cool too.
This is the car one, wasn't it?
Yeah.
A universal constant,
This was SIGGRAPH.
never diminishing, never ending.
It's fine. But this isn't how my video games look. He said he was going to talk only about gaming.
70 years of unrelenting progress.
We got a car. And it's not for like project cars. It's just Porsche.
Like a rendering for them.
This is a video. However, in my opinion, it looks better in real time because the resolution's higher. And what's amazing is that the geometry of that car is not a video game car. It's a full geometry of the real car. And the materials are captured physically accurately. And all of the lighting and all the shadows and the global illumination, all done in real time. Just an amazing piece of engineering. Let me show you now. This is work that's being done by one of the video gamers, Munfest in Eastern Europe. And this is really a fun demo. If you look when we show it to you, you can see that some of the stuff is just really, really amazing. And this is the indication of what next generation
weird,
gaming is going to look like.
Kind of.
Yeah, I forget what it's called.
Mark, are you going to do this one?
Yep.
Okay, so this is what USSR is was potentially going to turn out to be. Is that right?
That's right.
And so what's really amazing
This doesn't look realistic.
notice how crisp this is.
It must look better there.
This is in real time.
Because over the stream, it's not translating
Everything
well.
is in real time. And RTX on, RTX off. Notice the reflections were all broken. And the reason for that is because screen space doesn't allow us to reflect what is behind the object.
That wasn't
the
frame
soft
drop. That
shadows.
was turning ray tracing on and off.
The soft shadows
Yeah, I thought
result
for a second it
because of an
broke.
area
No, 'cause we're
light.
covering the
The
RTX
combination
on
of umbra and penumbra causes the soft shadows to look so exquisite. And that just
I
happens.
mean, the
with
shadows
ray
look kind of
tracing.
good.
Yes, but
Shadow
everything
maps
else-
you just
necessary.
don't notice it.
There's
Like,
an
if you're
area
into the
light just
storyline-
underneath this robot, and it's interacting with the light, and it's combined with the
That's
light
cool.
of the head, all being spun in real time. There's a reflection of a curved surface. Reflecting off of a curved surface is super hard to do. Really hard to fake.
That's off.
And
that's
screen
on.
space reflection simply breaks. There's another scene. You're seeing reflection and refraction of that, I guess, what would have been an aquarium.
I think they just need to have this implemented in a game that people actually care about. Like, one of the worst things that they
Reflection and
did was partner
refraction.
with Battlefield as the launch title, because that just already had so many controversies
Again,
by
the
itself.
soft shadows that you notice.
Didn't do well for them.
And then it's
there.
not even properly implemented. Shadow of the Tomb Raider still doesn't
Caustics.
have it. Metro Exodus is an okay series. It's not going to be the groundbreaking thing.
Nah.
Like,
It's
if they put it in
fantastic.
Anthem, maybe they could have.
Okay.
Everybody's hyped for that one next.
Yeah, I think.
Or if they
can-
partner with CD Projekt Red for Cyberpunk, I think that could be the driving factor.
Wow,
But
I don't know
they
whose
need
lab
people
this
to
is, but
want
it's
to
kinda
adopt
creepy.
this.
Yeah.
And you don't do that without the games behind it.
You want to feel like you're getting the best.
Ladies and
experience.
gentlemen, developers at Munfest. It took 10 years to figure out how to do ray tracing fast enough. And if not because of a groundbreaking piece of work about 7 years ago called deep learning, I don't think we would have been able to realize it in totality. But none of this is possible without the partnership with all of the industry to do so. And so I want to thank Cam and his team at Microsoft, Tim Sweeney and his team at Epic, Natalia's team at
just said
Unity,
Epic. It's gonna be in
and Tim's
Fortnite.
team at Frostbite.
Confirmed.
All of these amazing engineers work together to create what is now the entire stack for this new form of computer graphics that many call hybrid rendering, what we called RTX. One of the pieces of technology essential to making all of this possible
AI.
is AI. And so now the question is, how is AI applied to the future of computer graphics?
Deep
Let me
learning
give you
super
an
sampling.
example. This is a piece of technology
They
we
have
call
like a
DLSS.
time thing to hit.
Basically, with DLSS,
So
what we're trying to
I
do
would
is
guess
this.
60 minutes.
Well, first of all, AI. AI is a machine, a software that learns from experience. It learns from experience to predict the future, to make a prediction about the future, make a prediction about something. And so what we're doing here is that we're teaching this AI, and we call this AI DLSS. DLSS, it's a very large piece of network, trillions of operations, artificial intelligence network. This piece of software is going to write itself. And it's going to write itself, develop itself, it's going to reconfigure itself, adjust itself, learn by itself on top of the supercomputer we built called the DGX-2. This DGX-2 has 16 processors in it, 16 GPUs in it, and we have racks and racks of these working away, learning how to predict the perfect frame. It learns from ground truth. Ground truth is 64 times the resolution, 64 samples per pixel. So this picture is beautiful. It learns that picture should look like this. And wherever it's wrong, we send it back. It's called back propagation. We send it back, and then we give it another try. And it tries and tries and tries and tries again. And it iterates and iterates and iterates again on top of the supercomputer and runs for days on top of the supercomputer, a whole bunch of them. And we're teaching it one frame after another frame after another frame of all different kinds of images. Some of it outside, some of it from this particular style of image, some of it is photographic, some of it's cartoony, all these different types of styles. And it learns from all of this great content what it should look like, what it should look like. And then one day, we give it an image, and it goes through this neural network called DLSS, and ideally what comes out of it is a beautiful image. Ideally what comes out of it is a beautiful image. And the reason why it's a beautiful image is because if I gave you a low-res image, I bet in your mind you could figure out what the high-res image would look like. And the reason for that is because we've learned over years what it should look like, based on the few data points that you were given, what the perfect image should look like. In fact, you could even fill in missing pixels. There could be entire blotches of stuff that's missing, and we could still, because we're intelligent, we could still infer what is likely the right pixels to put there. We call this DLSS. This is the neural network that we created to improve an image. If we were successful in doing this, we could render the original image at a slightly lower resolution.
It's like if
run
we
it
were
through
successful
DLSS
in doing that,
and have it put out a larger resolution, and it would look fantastic. Not only would it look fantastic, because it goes through our Tensor Core processor, it would also do it so fast, it could actually improve the performance. Now, theoretically, suppose we could do AI infinitely fast, and I could render at 1080p and create an image that looks even better at 4K. Then what I've essentially done is taken a 10 teraflops GPU, for example, and made it perform like a 30 or 40 teraflops GPU. That's the dream, okay? That's the dream. If we could figure out a way to apply artificial intelligence to predict the perfect pixel, because it learned it.
You don't know what the dream is. This is your dream.
Then we could render at a lower resolution, and it could create higher resolution, effectively increasing performance and potentially even increasing quality at the same time. Well, we've been playing with this for, you guys have seen us play with this now for several months.
Are they going to announce it for Battlefield?
And we're making rapid improvement. And just recently, one of the leading developers in the world saw the work, and they were so excited by it, they're going to adopt it for an upcoming title, one of the most anticipated titles.
If you don't say
Cyberpunk. Wait to see it. It's a title called Anthem.
Oh,
it's a bunch of...
I had a feeling it was going to be Anthem.
Bunch of...
That's pretty good.
bunch of characters, and they're freelancers, and they jump into these exoskeletons that they call Javelin, and it's an action RPG.
Trying to think of the points
it's
yet
just
to
really
talk about.
Fantastic looking game. I can't wait to play it. And
that's actually going to be quite
folks
nice
at BioWare
to have DLSS.
Made a trailer for you guys.
Yeah, but and see, they call deep learning super sampling RTX, so they're gonna deceive people into thinking that it has ray tracing, but it don't. That's not ray tracing.
Technology has always helped us unleash our creative potential by giving players more immersive experiences than ever before. In Anthem, head out into a chaotic and beautiful world. Fly across wondrous lands in your Javelin exosuits. Confront deadly creatures. Formidable foes.
What was that one game? Was it called?
And awe-inspiring mysteries.
Yeah.
And it was like supposed to be MMO sort of.
Like something like that.
This just looks like an Iron Man version of Destiny.
Oh yeah. That's kind of like why my friends all hyped for it.
Nvidia takes us one step further.
Might be Destiny, but better.
By rendering our game with more precision.
You know, they're making it look so beautiful,
quality
but
textures.
those shadows look really good. Everything about this game already looks good,
combat have
but it doesn't have ray tracing. It's a weird title for them
We are
to try
happy
to
to
promote
announce
right
that we are working with Nvidia to bring DLSS technology to Anthem. Check out Anthem on PC with Origin Access Premiere on February 15th.
Oh, cool. So we'll have it on February 15th.
That's amazing.
Nice.
Guys. The developers at BioWare just did such an amazing job with Anthem, and I'm looking forward to do our best to make it better. Now I want to show you DLSS in action. There's recently, it was announced that 3D Mark released the world's first ray tracing benchmark. I'm going to play for it. I'm going to play for you here, and we're also going to show you DLSS in action. DLSS in action. Okay, so guys. So on this side is ray tracing on, but using the state-of-the-art in anti-aliasing technology called TAA, temporal anti-aliasing, that we played a huge role in inventing. This is as good as an image quality as you can get today at 1440p. On that side, on your right,
it's supposed to look the same. You're supposed to be looking at the frame rate.
On with ray tracing and DLSS. Both sides are ray traced. Both sides are 1440p. This one uses DLSS, and this one uses state-of-the-art anti-aliasing technology called TAA. I want to bring your attention to two small numbers up on the top.
Stream, though.
Yeah.
Not only is this image more beautiful, more crisp, it is also running at a higher resolution. Exactly the same GPU. Does that make sense? Are you guys following this?
FPS is in the top corner.
If you could, a little audience participation here. Who prefers this one? Who prefers this one?
Oh my. That wasn't a lead question
Notice
at
how
all.
crisp everything is. And the reason for that is because the DLSS network,
they're supposed to look identical
from a whole bunch of
because
really
TAA and deep learning super sampling are the same.
Really
they're supposed to have different frame rates,
images.
which they do.
And it learned how to reproduce it. It learned how to reproduce it using a supercomputer that we invented called DGX2, running deep learning, this new auto-encoding neural network that we call
for anybody
DLSS.
who's complaining about the frame rate, this is a benchmark. Do you really complain about the frame rate that you get in TimeSpy when you benchmark your graphics card?
On. This one is using TAA. Notice all the subtle details. Temporal anti-aliasing has some static artifacts. In motion, you don't see it, but when it's static, you see a little bit of flickering. If you could just ignore that. DLSS doesn't have that same artifact, but the important thing is look at the details here. Look at that detail. Look at that detail. Look at the crown moldings on top. Look at the chandelier.
Look at the detail.
It is just incredible.
I can't
from
tell
here.
the difference.
Look
They're
at
on
the
giant
patterns
projectors being
at
streamed.
the bar. This is the power of artificial intelligence. So what have we done?
Look at the detail.
With ray tracing, we added a ton more computing workload. As a result, frame rate drops. We then apply artificial intelligence with this powerful tensor core that's inside Turing that could learn from really high-resolution images and reproduce images that are beautiful, but because the tensor core processor is so fast and so powerful, it could do it so quickly that the frame rate is even higher. And so we now have the ability to not only improve an image, we can potentially even make it go faster. Now let me combine some of this and show it to you in a real game. This next game is called Justice. This game just came out recently in China by NetEase, and this is one of the most popular MMORPG games in China.
And it has ray tracing?
Calvin?
I've never heard of it, actually.
Okay.
Do you live in China?
And so here we're looking at Justice. Let's talk us through this.
The graphics look terrible. This looks like
Calvin,
something
you
out
still
of like Onimusha
here.
back on a
Here
PlayStation
we
2.
see the reflection on the floor and on the vases. RTX
Good ray
off.
tracing though.
RTX on.
And notice for all the computer architects in the audience, you recognize what I mean by screen space reflection. Notice the top of the cart is not in the frame. If it's not drawn in the frame, it's not in the screen. If it's not in screen space, then the rasterizer and the programmable shader has no way to reflect from it. And so the information doesn't exist. In the case of ray tracing, the information all exists. Okay, so this particular effect
So you
called
can get your PS2
screen
graphics
space
rendered in a
and
puddle,
screen
too.
space reflection is used for
Just what I
dynamic
always wanted.
reflections, simply doesn't work, and it breaks when the object is not visible in the screen. So this is an example of that. Notice on the vases, none of the objects are visible, and therefore, if RTX was off, all the reflections go away. Boop. Okay, Calvin, let's keep going. Look at the ground. Look at all the vases. In this particular case, not only are we reflecting on the water, the water is reflecting light that bounces on top. It's called a caustic underneath that bridge. Lighting underneath that bridge is called a caustic. This is real-time caustics. The first time that I think ray trace caustics has ever been done in the game. Look at under the bridge on the boat. It's just really exquisite and beautiful.
Yeah, we've been going for 50 minutes. No product announcement, just the same old nonsense.
Dang. It's been 50 minutes.
I mean, this is a new demo. I haven't seen this before.
Same.
I think they mentioned it.
Okay.
It might have been shown somewhere else.
Yeah, partially, but not this full, like,
you're going to see
PlayStation 3
fireworks
stuff.
reflected off the ground. And the reason for that is because there's fireworks out in the distance.
This looks terrible.
The fireworks are even outside of the frame.
This is legit, like,
and everything just
early
works
PS3
by itself.
graphics.
Well, there's a ray tracing
We could
demo
zoom
on
into
the
anything
PlayStation
with a
3,
reflective surface, and it's doing reflections properly. Look at that.
That's cool.
It's
but look
subtle,
at how
it's
jagged
exquisite.
everything is. And the terrible
All you have to do
textures.
is create this
Ray
ray
tracing
tracing
doesn't make
data
up for
structure we call
bad
the BBH.
graphics.
You have to trace the rays, which the APIs all provide for, and you have to apply the necessary reflectivity of the materials. And then everything else just works. Calvin, good job. Thank you.
Thank you, Jason.
Now, the reason why I showed you that is this. This particular game, with RTX off running on the same GPU, Justice in 4K, this video game in 4K, on a 2070 is 50 frames per second, on a 2080 is 60 frames per second, on a 2080 Ti, it's 70 frames per second. With with just normal mode, no RTX, no ray tracing.
That is
Of course,
terribly
ray tracing
optimized.
puts an enormous amount of pressure on the processor. There's just a lot more
Holy
work
crap,
to
that
do.
game looks awful.
And so what happens
it
when
takes
you ray
80
trace
frames
is the
with
performance
no ray tracing?
droops. A little sad. It looks way more beautiful. It looks way more beautiful, but the performance is a little lower. And then what we do is we turn on the rest of RTX, which includes DLSS, and it looks like this. Whoop. What do you guys think?
Whoop.
+1 for Jensen sound effects.
Whoop.
You guys want to see that again?
No.
So
Just
next
keep
time you
making that
guys
noise,
turn on
Jensen,
RTX, I know what's going to happen. You're going to hear this thing in your voice. Your brain goes, whoop. Just beautiful. Okay. All right, I got to show you one more game. I got to show you one more game. This is, of course, one of the most amazing games ever created, one of the most beautiful games ever created. It's called Battlefield 5.
Dang it.
And it's developed by a developer called Frostbite and the division of Electronic Arts. The engineers are just incredible.
Wait, isn't the developer called
And I showed
DICE?
you some of the examples of
Yeah,
previous
but they
works
use
that
the
they've
Frostbite
done.
engine.
And they've
Yeah,
done
but the
one
developer's not
groundbreaking work
Frostbite.
after
Yeah,
another
he said
groundbreaking
Frostbite.
work. And the latest piece of work that they've done is called
Isn't
Battlefield 5.
Anthem also
They
on the
were
Frostbite
so
engine?
excited
So,
about
yeah.
the potential of ray tracing, and they were one of the early
So I guess
collaboration
that's why
partners
it's
of
easy
ours
enough to
in
throw
developing ray tracing into
DLSS.
reality,
Ray tracing.
that they put it into
Battlefield doesn't have DLSS
Battlefield
as of yet.
5.
I don't
When we
think
first
Anthem would
announced it,
run with ray
people were so
tracing.
excited to see it. When we first rolled it out,
would be way too
the performance
unplayable.
was not as good as people expected.
Correct.
And in just a few short weeks, the engineers at DICE improved the performance by 50%, and the audience were just incredible.
cutting ray tracing by 50%.
People were so excited about it. Everybody's playing it with RT on. improving it. And here to help me show it to you
Everybody.
is Jonas. Jonas, where are you?
I'm right here, Jensen.
Hey, Jonas. Nice to see you again.
Nice to see you
Happy
again.
New Year. Welcome.
Thank you very much.
And
Who is this
Jonas works at
disembodied
DICE.
voice?
And show us what you're going to show us.
Sure thing.
Doesn't matter. Everybody's playing with ray tracing on.
If you can get it up on the screen. Perfect. So we are visiting the Netherlands again for this demo, the first few days of the Battle of Rotterdam.
What the heck's wrong with that guy's
and
arm?
one of the methods that we use at DICE to
Hands
achieve
don't
this
work. What is that?
amount of
That's a
believability and
weird
realism
link,
in our
boy.
game is physically based rendering. So what this means is that if you look at the,
Can't stop
at the terrain
looking at
here,
the
the way
arm.
that the sun and the light interact with the surface and the materials, you get a physically based look from it. The way the light interacts with it behaves how it would in the real world. And same thing when you look over the water here, you can see the way it reflects. And everything is physically based, which just makes it feel coherent and realistic. But science doesn't get you the whole way when creating a beautiful game, so many of our artists are also
Something
taking
is-
lots
I
of
can't even
reference
put my-
from the real
like,
world when creating
it's
our
normal
assets.
length forearm,
particularly
but
this,
something's funny
landmark
about that.
White House of Rotterdam here is recreated at almost a
Who
one-to-one
walks like that?
ratio.
Look at that window we're walking by. It looks amazing.
Yes, exactly.
Look at
Then
the
when
window.
you-
It
looks
the right
amazing.
here-
It looks like glass. You could almost reach out and touch it.
Yeah, this shows a great example of the combination of ray tracing and our physical-based rendering and the work that we've been doing with Nvidia. It really comes together here.
Hey, Jonas, look at the reflection of the windows in the buildings, on the buildings.
Yep, exactly.
Yeah, it's just
Ray
working.
tracing. It's super nice. But
Everything
of course, it's
just
not
works.
a beautiful Dutch city without its own beautiful canals. So we can also walk over here. And of course, this is not just any normal canal. It's a ray trace canal. And we see the boats and the barges
Even
nicely
better.
reflected down
I'm
there.
gonna go
as
to
you would
Venice and
expect.
demand some ray trace
Everything's
canals.
looking really nice.
Yes.
But I would like to dive deeper into ray tracing and show you something more. So if we move to another area on
That's
the
how
map,
people looked in World War II.
then here to the left in the scene, we have a Churchill crocodile holding, and I have my friend Pavel in there. So if you can say hello to the audience for us, that'd be really nice. Hello there.
Hey, wait. Look, check it out.
That's
Look
perfect.
at.
Wait, are they
we
allowed
can
to
see
show
him
that on
not
screen?
in the water.
Yeah,
Probably
exactly.
get banned off
He's
the
Do it
reflecting.
again.
Yeah,
What?
that's amazing. So yeah,
Yeah.
if you could do another favor for me and
Now, of
and
course,
start.
we would expect that in reality, right? These things that happen in reality, when we're able to reproduce it using computer science,
it's
it
not
brings
about
us so
reproduction.
much joy.
Yeah, exactly. It's super cool. So yeah, if you can do me a favor and we can start looking at some more ray tracing.
is
If
he
you shoot
faking
your
this much
fire cannon
enthusiasm?
across the scene here. then with ray tracing on, when
Now
looking
he's
down
peeing.
into the puddles,
Great.
even when the flame effects is off screen, we still get the reflected view of the fire as we would expect. But with ray tracing off, when we turn that off, even though the fire is shooting, you can hear it in the background.
Bull
we don't
crap,
see
it would
reflected
illuminate on the
anymore.
ground somewhat.
So then if we
Oh,
turn
bull crap.
RTX back on again and we move forward up to the tram cart, then inside the window of the tram cart right here.
Oh, look at that.
And again, you can see the flame flying through the scene, moving dynamically. And not only do we reflect the dynamic moving particle effect, we also get a much more accurate representation of the surrounding environment. So, for example, you can see there's a high fidelity reflection of the surrounding city.
I mean,
but with
reflections in
RTX
an
off,
FPS could be cool for like
then you
seeing
don't get
around
any of the
corners
same
to see if an
fidelity
enemy
as,
is there.
as you would
Fair.
before, even when running the game at
Like
high
if
quality.
you could see somebody coming through that reflection.
And then we've
Or like
implemented a
there's a puddle on the
special little
ground
neat
just at the
feature in
corner
this
and you
build
see
for
them
you.
running
So
up or
we
something.
can
Yeah.
slow down the time scale of
But
the VFX, and
not
if we turn
this.
RTX back
Not
on again,
this.
and then
That's
we
when the
can
game
start
becomes
shooting
pay
the
to win.
tank's cannon on the sign over there. Then we can see
Not wrong.
the explosion and the debris and the frostbite's destruction is also reflected in the ray trace view.
Wow.
Which, with RTX off, you lose all that detail, and this is just not nearly as exciting as it is with ray tracing on.
I don't tend to look at
But of course, we
cable
even
cars
with ray tracing on
when
again,
things are
we can move
exploding,
to
though.
the car.
Honestly, in the middle of action,
and
you're
even
not gonna
complex
notice anything.
surfaces like this is not a problem for ray tracing. So when we shoot our tank flame over it again, you can see it on the fender of the car.
Everything
the hood,
just works.
Everywhere, it's being reflected how you would expect. And a little fun thing is if we move to the back of this car here, and we move around it, then we can in fact see our own soldier reflected in there. Yeah. And that, of course, is together with the flame that's being reflected in the car, and not just the car, also the street windows to the side, in the tram, and everywhere, the whole environment, everything is being ray traced.
That's
It's actually
incredible.
really terrible
Jonas, thank
reflection.
you. Congratulations.
That's great. But I think
Congratulations.
we have this really, really cool weapon in the game. It's called a V1 rocket, and it's got a pretty big flame. I think it would be interesting to see how that looks when ray traced. So, Pavel, if you can call that in and drop it at the end down there, let's see how that looks. Right there. And that explosion is being ray traced again in the whole environment, how you would expect.
Oh, you see it in the windows, you see it everywhere. That's
Yeah.
really fantastic. Thank you.
Sure thing.
Those windows are way too
Jonas,
clean
thank
for
you.
a
That's
wartime
incredible
thing.
work. I think
So you can see
you
better.
see now the amount of computer science that's necessary for video games is really quite extraordinary, and it makes sense. And the reason for that is because we're trying to recreate virtual reality. We're trying to suspend you in disbelief. And as the rest of the computer graphics keeps improving, programmable shaders keep improving, photogrammetry improves, geometry tessellation improved, physics is improving. All of these different effects are improving the look of computer graphics. Then everything that's broken jumps out at you. Everything that doesn't make sense pops. The things that we really need to go work on are, one, we have to work on shadows, whether it's dynamic shadows or in global illumination, effects of shadow, reflections and refractions. Those three things are so hard to solve. If we can go solve some of those, in addition to everything else that we've done, we could really take computer graphics to the next level. But the thing that is really, really amazing, you saw this entire video game running, this entire demo
$250
was running with
RTX 2060.
on at 1440p, at 1440p. But what is amazing is that it was running on a brand new GPU. This brand new GPU, ladies and gentlemen.
So hard
I
to
would
see
like to
coming.
introduce it to you.
Just tell me the price.
Ladies and gentlemen,
Yep.
the RTX 2060.
That was the weirdest demo video.
Mm-hmm.
Incredible. That GPU, that entire demonstration was being run on this GPU here,
Please say
the
350.
RTX 2060, the long-awaited RTX 2060. It is here.
It's a short boy.
It is a lot shorter than the others.
It's like 75%.
A lot more compact.
So the RTX 2060, 52 teraflops of tensor core processing, 5 gigaarrays per second, 6 gigabyte
2070
frame
has
buffer.
6.
G6, the fastest memories in the world. Okay? That's what it took to play what you just saw, Battlefield 5, with ray tracing on. Now let's take a look at the performance. What you were looking at, if RTX was off, the frame rate would be about 60 frames per second. A really fantastic experience.
Yeah.
Really fantastic
Better than I was
experience.
expecting, honestly.
Battlefield 5, 1440p, 2 megapixels, on a 2060, over 60 frames per second. Now, when you turn on ray tracing, this is what happens.
Boop.
And for many,
He just made a disappointing noise.
They were somewhat disappointed by that, even though it was so much more beautiful. And so, as you know, we've been thinking about this for quite some time.
Deep learning, super sampling, and Battlefield.
And
yeah, we know.
We
Thank
know
you.
that ray tracing is computationally intensive, and it's going to continue to be computationally intensive, and that's the reason why we added the right proportion
ray tracing medium.
between ray tracing cores,
so we know.
RT cores, and tensor cores, so that we could apply DLSS to this, and as a result,
Just over 60, 1440p. That's not bad.
Basically back up to where it was without ray tracing.
ladies and gentlemen, this is my favorite demo right here.
As long as you tell us the price.
That's my favorite demo. That is good technology. How do they do that? Just like that. DLSS. It looks beautiful. And because that network, that DLSS network, was trained from and learned from so many high-resolution images and trained on this supercomputer, just tons and tons and tons of examples. This huge neural network has become smarter and smarter, and it can predict what is the best pixel to generate. And as a result, reduce the amount of computational load so that we could reduce the resolution and then use DLSS to infer a much more beautiful high resolution. The new Turing GPU has a brand new shader architecture, as I mentioned. We double the amount of operations that we can simultaneously process. We can now process integer operations as well as floating point operations at the same time. We also doubled our cache, and we have because we unified our shared memory and L1 cache, we have the ability to double that as well. So we would expect the performance boost relative to previous generations to be quite substantial. And as you can see, and with all of the other shader technology that you've seen published about Turing, for example, variable rate shading, multi-view rendering, mesh shaders, and just the hundreds of new improvements that we put into our shader technology, shader architecture, you could see that the performance on any games is dramatically higher. But what's really interesting is this, and we would expect this. As games become more and more complex, and as their shaders become more and more complex, we would see a trend line of Turing over Pascal to continue to advance. And the reason for that is these shader programs are getting larger and larger and larger. And it has the ability to perform up to almost 2x on Wolfenstein 2, which takes advantage of variable rate shading that we have in our GPU. I'm pretty excited about Doom Eternal coming out this year using the same engine. And so I think that Turing turned out pretty well. What do you guys think?
They're doing it at 1440p at high, which a 1060 was never really designed for.
Well, turns out gamers need more performance than ever. If you plotted out all of the games that we have in GFE, these are all the games that our GeForce gamers are playing over the last several years. In order to sustain 60 frames per second at 1080p, you would have to triple the amount of computational capability over the course of the last 4 to 5 years. Meanwhile, resolution has increased from 1080p 60 hertz to 1440p 144 hertz, which is the reason why, if you take a look at the number of X60 class, 60 class gamers continue to grow over the last several years. In fact, it almost tripled over the last several
You
generations.
keep raising the
last
prices
4
and you're
years.
dropping the 70-class
And
gamers
so if
down.
you take a look at the 2060 now, compared to the install base of GeForce, this is kind of what it looks like. I mean, this is pretty extraordinary. A RTX 2060 is higher performance than a 1070 Ti. A 2060 is higher performance than a 1070 Ti. And if you take a look at the rest of the install base, I took the 3 most popular GPUs, the 960, 970, and the 1060, which are in abundance in our installed base. It represents about 1/3 of our installed base. The step up is really quite extraordinary. And so 2060, higher performance than a 1070 Ti, which is in the market for about $449, $450, and about 1/3 of our installed base opts for the X60 class and above.
Because of the price, not
2060
because
was
it's a
really
60
created
class.
To bring all
People
of
were
those
getting a
installed
970
base
before that.
to next generation. 2060. Really fantastic performance. Ladies and gentlemen, I am delighted to tell you that the 2060 is available for $349.
Gold it.
You didn't say from.
$349. You can enjoy next generation gaming. 52 trillion tensor flops, 5 gig arrays, 6 gigabytes of G6 memory, $349. Perfect for the entire install base. But
So that's
not
$20
all.
cheaper than a 1070. When
I
it
got
launched.
a special,
Really?
Yeah.
special gift.
1070 or 1070 Ti?
We have a special bundle.
1070.
We're going to bundle with 2060 and 2070. You get either Anthem or Battlefield 5. So you can enjoy DLSS or DLSS and ray tracing on Battlefield 5.
Okay, so
and
that's
with
a
$2080
$100
and
increase
Ti,
from
you get Anthem
the original
and
1060.
Battlefield 5. Incredible value.
Jeez. $50 from the Founders Edition 1060.
Maybe they're doing this
The
to
2060
bump everything up
is
a level,
here now.
and then have
The number of 2060
be
graphics
more-
cards you're going to be able to enjoy and buy
They're just
all
doing
over
it to
the
make more
world.
money.
The
what
designs
they're
from
doing.
all of our AIC partners are just beautiful and exciting. They'll be available on January 15th, next week. Ladies and gentlemen, the 2060 family.
Cool. Still like the
PC
reference.
gaming companies are so excited about it. A whole slew of new PCs are being built
It's not 2 free
to
games. It's
welcome
1
this
free game.
next gen of gaming. Hundreds and hundreds of desktop PCs are being built and offered with the RTX 2060 all over the world. You're just going to be able to, starting next week, be able to buy 2060s everywhere. So, ladies and gentlemen, the RTX 2060 is incredibly cute, quite frankly. Look how cute he is. It's pretty amazing, right? It's the perfect size. It's the perfect size. Love this. Paul, thank you.
So cheaper than a 1070 at launch and better than a 1070 Ti.
5 years ago,
It's not good for an X60
we announced
class,
something really,
but
really
it
important.
makes sense in the upgrade
And
pricing.
some of the luminaries of the video game industry, friends of mine in the industry, got together to help us celebrate it. And it was the launch of G-Sync. It was a revolutionary new technology that combines the GPU, a new processor that fits inside a panel, and new panel designs that allowed us to achieve a level of silkiness and smoothness and latency, responsiveness that was simply unimaginable until then. We call it G-Sync. And Tim Sweeney joined me, and Johan Anderson from DICE joined me, and of course, you guys know John Carmack joined me. And they were so excited about this new technology. And we've advanced it incredibly in the last 5 years. And it's proven to be every bit as important of a technology for gaming and for modern design as we have predicted. And frankly, a lot more. We're now on our third generation. In order to create G-Sync, the experience, it requires 4
All right,
basic
this is a
things.
2-hour keynote.
The first thing that you have to
I have
do
a
is you have
feeling,
to
yeah.
create the processor inside. This processor deals with the color, it deals with the
And it costs
overdriving of the
$500.
pixels.
Just
It
the processor.
predicts when the next frame is going to be completed so that it could decide whether to repeat this frame, or hold on long enough so that the next frame would just finish so that it doesn't tear. So it has to predict and avoid tearing, and as a result, the frames would show up on the screen at exactly the time that it was completed. And you avoided the stuttering that happens with VSync, and you avoided the tearing that happens when you have VSync off. Gaming in the past was about tearing or stuttering, but you get one or the other. With the invention we call G-Sync, we were able to avoid both.
Now we put it in giant TVs.
The performance and the experience was incredible. But it required
Doesn't
us
that sell yet?
to invent the processor.
Literally
It required us to
$5,000.
work with panel makers to design exactly the right panel and exactly the right performance. And we had to calibrate and test it like you can't believe. And the reason for that is because they're stuttering, they're blanking, there's flickering, there's all kinds of issues that happen when you're driving that panel right up to the edge. And so this entire system, the software, the GPU, the processor we call G-Sync processor, which is now Gen 3 and supports HDR, this incredibly fast response time so that we have no blurring and no ghosting, all made possible because of this system that we put together we call G-Sync. Well, at this show, you now have 3 amazing G-Sync monitors. And they're 144 hertz, they're 4K, they're HDR 1000. The high dynamic range is so beautiful. The reviews are just incredible. And you should go check it out. This is the pinnacle of what a monitor and a TV can be today. We call it G-Sync Ultimate. And we have partners all over the world.
G-Sync Ultimate
has a monitor called Swift. HP just offered a TV, a gigantic gaming display, the Omen X Imperium 65, and Acer, the Predator X27.
Whoa, this PG27UQ that was announced 2.5,
utterly
3
beautiful
years
monitors,
ago.
and they're silky, silky smooth. Well, the invention of
This thing was announced
G-Sync
ages ago.
and us working with the ecosystem inspired all of the panels to get better. And we worked with the VISA industrial standards body to create what is called async, adaptive sync. Adaptive sync has been adopted by panel makers all over the world. And there are millions of adaptive sync monitors manufactured today. It really defines the baseline of what a gaming monitor is. And so we've been looking at the adaptive sync market now for a couple years and trying to figure out how we could help it. And the unfortunate thing is without the processor, the software, the GPU, the system design, the panel calibration, in the factory testing and the calibration of color and tuning, and the testing, the integrated testing between the GPU, the software, the game, and the monitor, and to do that repeatedly for every single monitor that's made, you're simply not going to have a good experience. And so we decided, you know what we're going to do is we're going to dedicate ourselves to just go figure out what is possible. And so this is what we did. There are 550 monitors that today are async monitors. There's 6 million of them shipped. There are 70 G-Sync monitors, and they all work perfectly. And so what we've done is we've gone out and we've tested all of these monitors. And we just started from one. And this is kind of what we found. Guys, can you play this one? This is called blanking. There's a whole bunch of versions of blanking, but basically, every so often, the synchronization just doesn't work out and you see black. This one is called pulsing. The color just kind of pulses at you. And the reason for that is, again, the synchronization is, and the reason for that is, as you know, that we're updating the screen, we're updating the display at just a moment when the frame is complete. At just a moment when the frame is complete, and not before that. Okay? And it's asynchronous. Every single frame is different.
Like this is a
and so it's variable refresh.
Company.
Every single frame
Intel.
is refreshed at essentially a different refresh rate.
They supported
and
that.
so if it's not exactly perfect and the overdrive isn't tuned just right, then you get all kinds of artifacts or you get a really wonderful experience. If everything just works, it's just silky smooth.
Everything
It's
just
the best
works.
experience ever. It is just unbelievable. And if you get one of the new ones, it's impossible for us to reproduce the experience for you. But if you get one of our new ones at 144K, at 144 hertz at 4K with G-Sync HDR, you simply can't believe what you're looking at.
That's my favorite resolution.
No movies is that silky smooth. No TV is that silky smooth. This is a monitor that is built to a perfect specification. We call it G-Sync Ultimate. But we went out and we tested all of these, and this is what we've kind of learned. We've tested now about 400 of them, 400 monitors. Of the 400, 12 of them passed. 400 async monitors, 12 of them passed. But what we're doing is this. We're announcing today that we're going to test every async monitor the world has made. And for the ones that pass, we're going to certify them, and we're going to optimize the software to support them, and we're going to turn it on natively in our software so that whatever GeForce customer enjoys that panel can now enjoy it as if they've purchased a G-Sync.
Dang,
monitor.
that's actually really impressive.
January 15th.
Wow.
I thought they were going to go that direction when they talking about all the panels.
Okay. I'm okay with this.
Same.
There are 150 other monitors to test.
Dang.
We've been at this for months and months and months, and the driver team has been working on it and tuning and optimizing, and we've found 12 of the 400 that gamers would consider to be functional adaptive sync monitors. And they're listed here, and we're going to continue to test them. And for the ones for the gamer who just wants to try it, we have it in our control panel so that you could just turn it on. Okay. But going forward, we're going to try to test as many of these. So
I mean, it's only those 12 models, but
one of the world's most advanced.
They're going to be cheaper than the G-Sync ones. Okay.
And we're just going to test them as fast as we can. Okay. So announcing the G-Sync compatible monitors.
That's something I can get behind, hands down.
I was not expecting that. Well done.
You know, gamers, this may be a surprise to non-gamers. Gamers don't just play games. They do other things.
They do?
They play games. They play other types of games. They play first-person shooters, MMORPGs.
They don't just game. They game other games.
Battle arenas. They don't just play at home. They play it at their friend's house. They play in school. They play some at work. I know my guys do. We pay them good money to play video games at work. And so we know that gamers don't just play games. They do other things. It turns out that because we have such a large install base, we know some of the things that they do. For example, they do animation. They love animation. There's about 1.5 million animators in the world. There are video enthusiasts. They make beautiful, wonderful movies. They tell stories with movies. One of the most amazing phenomenons around the world is game broadcasting. Broadcasting like you're a broadcaster while you're playing a game and talking about what's happening, teaching other people what to do, commenting about what's happening around in that game, and broadcasting it to all of your followers.
We're calling them broadcasters and not streamers.
PewDiePie, is that right? 75 million followers. $3.5 billion is generated by these broadcasters as their followers follow them. There are about 8 million game broadcasters, and they broadcast on Twitch and they broadcast on YouTube, and 80% of them use the
Mom, I am not a streamer.
OBS.
I'm a broadcaster.
Created by this young man named Hugh.
Everyone's going to change their Twitter bios now.
And we worked very closely with Hugh. He's He manages a community of developers, and OBS today is the industry standard, the world standard reference for video game broadcasting, which has to capture the game, encode the game, and stream the game. And then lastly, VR. 4 million HMD VR displays have been sold for PCs in the last several years. There are now 3,800 games in Steam. It's being used for architectural design, automotive showrooms, virtual showrooms. One of the most exciting and interesting applications is virtual movie sets, which makes perfect sense because when you're making a live action movie, the director is in the scene and they're directing the actors. When you're creating an animated movie, the actor's not in the scene. The director's not in the scene. Using virtual reality, we can now put the director into a virtual world where they're inside this virtual scene creating an animated movie, live action animated movie. And so that's an application of VR. There's so many different applications of VR. And so these are all the different examples of how our game users are using GPUs. And today we have some really exciting things that we're announcing. When we're developing Turing, we're thinking about all of these different use cases for our gamers. We want to build them the ideal PC for the gamer. Not just the ideal gaming PC, but the ideal PC for the gamer. And all of the applications that they use it for. So today, I'm excited to announce several things. We're announcing that the RTX GPUs, every single one that we've shipped, will be able to accelerate Arnold, which is one of the leading renderers that will go into Max and 3ds Max and Maya. And so for anybody who's doing 3D animation, modeling and animation, this is fantastic. If you look at CG Society, all of the different arts that people are creating in 3D are just beautiful. We announced today, oh, did I announce it? We're announcing today that we're partnering with Red, the cinematic video camera company, so that all of your RTXs that are desktop 2080 and above will be able to decode, interact, edit, color correct in 8K. And we'll be able to do it also in 6K in some future products. But 8K video editing. We're announcing today that we partner with OBS to create pro-quality broadcast streaming. Now, the reason why it's been so hard up to now is if you take a look at most of these systems, they have 2 PCs. OBS, most broadcasters with OBS have 2 PCs. One of them, which is playing the video game, and its output goes into a capture card, which goes into another PC, which is doing software encoding. And the reason why it's doing software encoding is because the quality needs to be super high. The reason why it's a separate PC is because they want that encoding to not affect their gameplay. And so they encode, they capture, they encode, and they stream it out to the various sites. With RTX, we've done several things. The first thing that we did was created a pro broadcast quality encoder. So our encoder can now achieve the level of quality that you could do with professional broadcasting. The second thing that we did was we created an SDK that allows us to capture, encode, and stream without affecting the CPU, all done on the GPU. So the load on the CPU is as small as possible. And the third thing that we did was working with OBS and Hue, integrated our SDK and all of our technology into OBS. As a result, 8 million broadcasters will be able to enjoy streaming with just a simple setup. Not to mention, they can also broadcast while they're using their laptop someday. And then lastly, we're announcing that we're partnering with HTC to take advantage of some of the technology that we created for Turing, for VR. Inside Turing, there are several technologies designed just for VR. The first one is it's the first GPU that comes with virtual link. Basically, audio, video, data, and power now comes from one wire. It's called a virtual link. And so the number of wires no longer hang all over you, just one elegant wire that connects the GPU to the head-mount display. The second thing is using multi-res rendering and eye tracking. If the head-mount display has eye tracking, then the multi-res, the variable resolution rendering, allows us to reduce the resolution rate on the outside of the peripheral division and focus all of that computation to the center. So we could either improve the resolution, improve the computation of detail, or reduce the load and therefore increase the performance. We're announcing those technologies with HTC. They have a special press release tomorrow, so be sure to tune into that. 4 announcements associated with Turing for each one of the use cases that we know our gamers do, so that we could create the perfect GPU for gamers, not just the perfect gaming GPU. 2 years ago, I like to get past this video, this image as fast as possible. 2 years ago, we invented a technology called Max-Q. We announced it at Computex. And Max-Q is about extreme power management. And the problem we were trying to solve is to create a laptop that allows a gamer to enjoy the highest possible gaming capability, but in a thin and light laptop. And so we created this thing called Max-Q. It starts with architecture. Our architecture in rendering any game is so much lower power than anything out there. Design, extreme power management, process tuning and centering so that we could identify the perfect different levels so that in a laptop environment, in a Max-Q environment, it could be high performance as well as low power. The integration between software, the GPU, the system design, and also thermal management and power regulation, that entire system was designed together so that the energy efficiency could be the maximum. And then lastly, one of the most important things is GFE. We literally tune every single game to be optimized for laptop use. We call it Max-Q mode. So that when you download a setting and then download the driver for your laptop, it is perfectly tuned for that environment. The combination of all this suite of technology we call Max-Q. Well, today, this is really something. We're announcing 40 notebooks for RTX.
January 29th.
This is an amazing number. GeForce RTX laptops. 40 new models, the largest number of models we've ever experienced. And the reason for that is because it turns out the GeForce laptop is one of the fastest growing gaming consoles or gaming platforms in the world.
Only the 1050 and 1050 Ti versions.
The numbers of notebooks that people are buying for playing games is really quite extraordinary and is growing incredibly fast. Well, RTX notebooks is now available from every single OEM in the world. It is going to have 40 new models with 100 different configurations. 17 of them are based on Max-Q. 17 of those notebooks are RTX notebooks that are thin and light. And it's going to be available on January 29th. Incredible, incredible supports. Now, Max-Q, take a look at this. So when we announced Max-Q, this is what it looked like. This is what a gaming notebook looks like. And there are many still that are made this way. And the reason for that isn't because of anything aside from the fact that the gamer wants to use it as a desktop replacement. They want to take their desktop PC, essentially. They want to take their gaming PC to LAN parties and to their friend's house. And they want to game at its full potential. And I think that's fantastic. And we keep building these. However, there are many gamers who would like to have their gaming laptop be as thin as
there's like 9 thin gaming laptops, and they make it look like it's this massive improvement.
And we call that Max-Q design. If you look at the difference in thickness and weight.
Yeah, he said that they'd be available from every OEM. Are they available from Soldier Boy? That's what we need to know.
An incredible growth in the number of GeForce laptops that are made. If you take a look at last year, the first year of announcement, we had 7 new Max-Q notebooks at this time. This year, this is how many we're going to have, 17. 17 new Max-Q notebooks, and they're exquisite. I'm going to show you in just a second. And the year just started.
Exquisite.
The year has just started. And so I think that gaming has never been the same. And let me now show you a couple of them. This one is from MSI. This is the GS65 Stealth. It's a beautiful laptop. 15% lighter, 10% smaller than last year's Max-Q. And it's 2.5 times the battery life, 8 hours of battery life, 144 hertz with this thin bezel. It's just really, really beautiful. Now, here's the performance of it. It's faster than a GTX 1080 desktop. This thin little laptop is faster than a 1080 desktop just recently. It is twice the performance of a PlayStation 4 Pro, the most powerful game console out there, and just 30% of the volume. It's 1/3 the volume, and it includes the keyboard and a battery. It runs 60 frames per second, Battlefield 5 with RTX on. It can do 6K red editing. The decode, the debarring, the color correction, 6K video editing in full frame rate, and it could do interactive 3D. Let me show it to you.
Someone hand the man a laptop.
That was not the game plan. Was that the game plan? This is what happens when you don't rehearse.
AMD's on Wednesday. It's on the 29th.
Whoa. Ladies and gentlemen.
Or on the 9th,
this
sorry, not 29th.
Is a Gigabyte 2080 notebook. 2080 RTX laptop.
That looks weird.
Look how thin it is.
It's like a trapezoid.
Battlefield 5.
Might just be the lighting.
RTX on. I think I'm playing Marshall. There. You try to do this upside down. Big talker. Here. Yeah, this is going to help. This gun is bigger. Here, take that.
Oh, look at that stutter.
Take that, Marshall. Come over here.
No, that thing looks like a trapezoid. That is a weird-looking laptop.
All right. Ladies and gentlemen, I think we have redefined mobile gaming. This is twice the performance of a PlayStation 4 Pro. Look at this thing. Next-gen console in my hands right now. Ray tracing on. DLSS on.
Everything just works.
Laptop thin bezel. It comes with 1080p or 4K display. It's so incredibly thin. And because I take my vitamins, I could hold this like this for as long as you like me to hold this. And this is just beautiful. And I can imagine using this for work, and you can, video editing and 3D animation, and it's just incredible. Ladies and gentlemen, a 2080 RTX in my hand. Very good, Marshall. Marshall, thank you. Thank you very much. And it comes with a whole bunch of versions. There's 2080. Here's a 2060 version. It's 1.6 times the performance of a place. Whoop, what just happened? What just happened?
What?
Was it me again?
What just happened?
So this one is a 2060 RTX from Acer. 1.6 times the performance of the PlayStation 4 Pro. It's faster than the GTX 1070 desktop. It's unbelievable. That's a high-end GPU just a few months ago. 60 frames per second. 4K red video editing with the 2060. Basically 4K video editing of the most raw version, cinematic version of video, and interactive 3D rendering. This one's from Acer. I want to show you a couple of fun things. This is called Ansel. One of the things that's really, really cool is the number of people who are using our Ansel program to take game photographs. They use it with the free camera capability. So you could be inside and you can change your camera, pause the game, change your camera, take a picture. You could use it with our AI super resolution So the way you play is one thing, then we can up-res it like you can't believe and turn it into a poster. You could turn on super ray tracing mode. You apply all kinds of interesting filters to it. You could create virtual reality scenes, images and photographs, 360 photographs, and you can export it into Photoshop. The number of people who are using this is just crazy. It's just so much fun. And the reason for that is because video game is not just gaming anymore. Video game is a form of art. And so let me show it to you. Henry, we're going to show you a couple of examples. So this is, as you saw earlier, this is Justice. And so while you're in the game, you could decide to turn that into a photograph.
Why use this game as a demo at
Photo
all?
Mode. This is Ansel. And so we could apply some different filters to it. We could either take a beautiful picture from the free camera, or you could apply a filter to it. And in this case, Henry's going to apply a couple of filters to it for us. Okay, so this is the painterly mode.
2 times the performance of a PS4 Pro. Looks as good as a PS3.
And this is the water painting mode. And so look at that. It almost looks like something that somebody painted. And then I could even put my stamp on it. You know?
Oh my.
You know, Henry did this for me, and
He's
that's
trying
my
to sell
Chinese
it.
name right there.
That looks
And,
awful.
I could put my name on that.
Oh, heavens.
And share that with people. Okay, fantastic. And so, thank you, Henry.
Thank you.
So that's called Ansel.
That's called bad.
The thing that's really quite amazing is just the beautiful pictures people are taking. And so we thought we would celebrate this. These are pictures that are taken in ray trace mode, Battlefield 5. Look at this. This is a video game. Ladies and gentlemen, this is a video game. The work that the folks at DICE did is just...
I was about to say the exact... I was wondering if it was too mean to say.
Northern skies, northern lights. And this one's really amazing. It's just incredibly beautiful. And so we decided that we would allow them to post that up on our website, Shot on GeForce, and we would share it on Times Square. Okay, we would share it on Times Square, and people all over the world would be able to enjoy this. So take a look at this. This is shot. This is going real time now. This is not real time. This was pre-recorded, but we're going to share these beautiful photographs to visitors from all over the world and share the beautiful pictures that are being taken by these amazing photographers. This is fun. I could use a hot dog right now. Okay, thank you. So, ladies and gentlemen, this is it.
This should have done.
This is our announcement.
PewDiePie billboard.
GeForce RTX. GeForce RTX. The first announcement is the RTX 2060 is available January 15th. Amazing price of $349. Higher performance than a 1080 Ti. Over 50 teraflops of Tensor Core processing. 5 gigarrays. Running Battlefield with RTX on at 60 frames per second.
Did you say 1080
Available
Ti?
all over the world from our incredible partners, AIC partners, starting January 15th. The second announcement is we announced that RTX laptops are going to be available from nearly every single computer maker in the world. There are 40 different models available of all different sizes, in different configurations, 260, 270, 280, with 1080p, 4K panels. They're thin, incredibly beautiful thin laptops. 17 of them are Max Q. Many of them could replace your desktop. You could use it for playing games, for broadcasting, for 3D animation and modeling and 3D design. You could use it for high-resolution cinematic video making, as well as
I think it's going to be
amazing for VR.
Presenting like
It's going to be available on January 29th. The thinnest, the most powerful,
the most exciting announcement
the
they had
ever
was
made.
the
I want to take this moment now and thank all of our developers that worked with us on RTX. This is an endeavor that was long in the making, but it was a journey we didn't take alone. And so without the help of all of our developer partners, this wouldn't have been possible. So our creative department made a short video to celebrate and acknowledge their amazing work. Let's play for you.
Not to see. That doesn't even have ray tracing yet.
Never retreating. Behold the line. We advance the front. But no battle is won alone.
Everything just works.
Thank
That
you
would've
all
been
for
perfect
coming.
if it
Have a
had been there.
great CES. Happy New Year. RTX is here. Next gen is on. Let's go. Thank you.
Everything just works.
Thanks for watching.
Okay, well, so that's everything that we've got from Nvidia. It looks like the RTX 2060, everything that we released in the previous video is pretty much spot on. Slightly the same as a 1070 Ti, going for $350. It looks like, I mean, compared to a 1060, that's $50 more than the 1060's Founder Edition price. It's $100 more than the 1060's MSRP price. So that sucks. It's definitely a price increase. But if you compare it to the 1070 launched at $380. So it's a $370. It's a $20 price cut off of the 1070 class. And then the 1070 Ti was like $450. So it's $100 cheaper than that for the same performance, except for 1070 Ti's. On the new market, we're going for about $370 a couple weeks ago, and then on the used market, you can find them for $300 or less. So it makes them a better buy in that scenario. But if you want something new, and then you also want the ray tracing for Battlefield or DLSS for Anthem, then I think the 1060 is going to make more sense than the 1070 Ti in that instance, to be honest. The mobile stuff was something we already expected, but then I think the FreeSync monitors, that is the coolest thing that they announced. The fact that they are working to find all of the FreeSync monitors that they consider quality enough to implement G-Sync on. So we're going to get G-Sync implementations on much cheaper monitors, which is pretty epic. So I would expect the sales of those specific versions of the FreeSync monitors to go through the roof, which is pretty cool. So good job to Nvidia on that one. Like that, I don't think that was a move most people were expecting at all.
Like when they started like hinting towards and like mentioning other, brands, I was like, okay.
Especially with Intel already committing that they're going to be supporting adaptive sync. The fact that Nvidia is also going to be supporting adaptive sync, just not crappy FreeSync monitors, which makes sense because there are garbage FreeSync monitors out there. So I'm sure that there's more quality ones than the 400 that don't qualify for their program. But if they have specific criteria, they have specific criteria. What do you want? Yeah, Natty. They officially announced that they're going to be supporting select FreeSync monitors as G-Sync through the NVIDIA control panel as of January 15th. They listed the monitors that are now capable. They're going to be testing the rest of the FreeSync monitors that are out on the market to find which other FreeSync monitors are going to be G-Sync compatible, which is pretty cool.
At the moment, there's only 12 models that they've approved.
Yeah. So that's pretty dope.
Yeah.
I'm okay with that one. The 2060, people are going to be pissed about that one. I don't think it's that big of a deal. I think it's okay. It's better value than the 2070, 2080, and the 2080 Ti. That is for sure. Yeah. It's a better card than all of those. So
It comes surprisingly close to the 2070. Like
the 2060?
Yeah.
Yeah, well, when it has 5 gigarrays and the 2070 has 6, it's 86% of the performance. That's $250 off of the $600 that they're charging for that thing on the Founders Edition store. So that's cool. And he didn't say from $349. He said it was $349, which is a notable difference from the previous announcements that they've made.
Makes me a little hopeful.
A little bit. So I think that's basically it. Everybody in chat, let me know if you have any dying questions that you want us to talk about. Other than that, we're probably going to call the stream a quits. We're going to record a video on this. We'll get a video out about all of these announcements so that you can be up to date on that, and we can have that going. You guys aren't Twitch peasants. I love Twitch. Link for the FreeSync monitors. It was shown in the stream. We'll have it in our video. I'll make sure that we put it in there. So just give us a second. Like, give us a few hours. We'll get that recorded and sent out to you. I really do. Yeah, there was no Metro Exodus demo, which was really weird. It felt like they pulled from talking about that altogether, and they're just going to push Anthem instead.
I feel like they want to get more buzz around Anthem.
Well, the only thing that I would probably boil it down to this. The thing that they know they can't sell the cards on is ray tracing, which is all Metro Exodus has. It doesn't have deep learning super sampling. Anthem has deep learning super sampling, so you get better quality and better performance. So it makes sense they're going to sell the performance side of things. If Metro Exodus implements DLSS, they'll probably push it more then. But with them releasing so close together, the one that makes sense to push is the one that people will actually see a performance benefit from picking up the RT cards, which would be Anthem. So
they're obviously going down that route now because...
Yeah. That sucks. Founders Edition price is same as AIB cards. It seems like it. He didn't say from $349. He said it was $349. He didn't announce two different prices. It seems like it is that way. I'm not actually sure.
Yeah.
There were the new OBS features.
Like, it's cool, but at the same time,
Yeah. What time will you stream for AMD? That's on Wednesday. That's on the 9th. So we just have a little while to wait for that. $349 will be $600. No, because the 2070 is $600. They're not going to do that. What is the Red partnership all about? It's about Linus. So they basically saw that Linus needed help with editing Red. So they said, you know what, we'll just integrate support and then give you the GPUs, and then you can chill us a bit longer. That's a joke.
For anyone who didn't catch it.
Anyone who can't catch that. Yeah, there was a list of FreeSync monitors announced. I don't have the list. It wasn't on the internet. It was in the stream. So you'll have to wait until we publish our video because we'll put it in there. Other than that, yeah, we're going to be done. So thank you, everybody, for tuning into this stream. Much appreciated. We'll catch you in the update video that we're going to do. We're going to be doing our remote CES coverage just like we did last year. So get ready for the beauty of Pretoria coming to you from your screens while everybody else is in Vegas. And it's just a known fact that Zebras are better than Vegas lights. So we'll have that in our next video. And with that being said, goodbye.